Okay, let's talk about D block elements, because D block elements are your transition metals. They are columns 3 through 12, and they start at period 4 or row 4. They contain filled or partially filled D orbitals. If you're wondering how the blocks get their names, it's from the different orbitals that we will talk about in a couple of units. They have a large properties that they share, including conductivity, luster, and malleability. The big thing in the transition metals is that you cannot memorize their charges. Almost all of them will form a cation with multiple oxidation states. Oxidation states meaning different charges. So you always have to be given the charge of a transition metal, and they're always positive. So transition metals are always positive, but you have to be given the charge. And copper is the most conductive of transition metals. Here are some interesting things. There's really little variation across the rows between atomic radius, ionic radius, electronegativity, ionization energy. The 4 trends we're going to be studying on Monday or next week, none of them really change. They're all pretty much the same across the D block. But they have wide variety in physical properties. They're most in hard solids with high melting and low boiling points, but all of those are determined by their electron configuration. So the ability of the unpaired D electrons to move into the valence levels increases melting, hardness, and boiling points with the more unpaired electrons there are. I can promise you, I'm telling you this now, but that's not something I really test on. Here are, if we're looking at the D block, here's how they line up in terms of electron configurations. Numbers. So column 3 is D1, column 4 is D2, column 5 is D3, column 6 is D4, column 7 is D5, column 8 is D6, column 9 is D7, column 10 is D8, column 11 D9, and column 12 is D10. And that is the overview of the D block.